Okay. Okay. Well, let's go ahead and get started. So a couple things I want to do today. First, we'll go ahead and take a look at that quiz. If you have any questions, your class average was a 79.1, so that is a huge jump from the previous one, so fantastic. After that, we'll talk about the vertex form homework, and then we'll go ahead and move on to the next lesson where we're solving quadratics by factoring, and that'll take us into tomorrow and the end of the week. All right, so questions about what's coming up? Okay, well, let's see here. All right, so here is the quiz from yesterday. Any questions? Number one? Okay, we'll do number one. Number one or number three? Okay, so for number one, give the axis of symmetry, vertex, and then graph the function. Give the domain and range in interval notation. Okay. So a lot of people did, even if you didn't give that to me in interval notation, if it was correct, I still went ahead and accepted that. So what was that expression that was super important with standard form? The opposite of B over what? Over 2A. There we go. So we have an A, a B, and a C. Okay, so it looks like the opposite of B is a -8 divided by 2 times A. A is 2. So -8 divided by 4, we're getting a -2. Now remember the thing about that's your axis of symmetry, but I did ask that you go ahead and write it as an equation. So x equals -2. So if you put -2 with no x equals, that's why you got a point off. Okay. Now that's also half of my vertex. -2 and then something. I'm going to put this vertex right here in the middle. Okay. Now how do I find the corresponding y value? We plug it back into the function. So everywhere I have an x, I'm going to replace it with -2. So let's see here. F of -2 equals, so 2x squared becomes 2 times a -2 squared, plus 8x, 8 times -2, and then plus 2. Okay, so let's see, -2 squared is 4, times 2 is 8, minus 16, and then plus 2. So what am I looking at? A -6. There we go. So there's my vertex. Okay, so let me go ahead. I'm just going to identify the origin because these are not bolded. Okay, so the origin's right there. So -2, 1, 2, 3, 4, 5, -6. Here's my vertex right here. Now we just need a couple of other points to go ahead and see what this looks like. All right. From -2, we're going to count above and below by ones. So this would be -1, 0, 1, -3, -4, -5. And we'll just go ahead and plug in, one of these because I think by now we're getting the idea. Let's plug in -1. So f of -1, 2x squared is 2 times -1 squared plus 8x plus 8 times -1 and then plus 2. Okay, so -1 squared is 1 times 2 gives me 2 minus 8 and then plus 2. All right, so it looks like if I plug in -1, I should get what? -4. Remember, you should be able to see the symmetry with the y values in your table. So if -1 gives me -4, then -3 would give me the exact same value. And then you just go ahead and keep plugging in. Let's see, both -5 and 1 would have given you 12, and -4 and 0 would both give you 2. Okay, so let's see here. We have a -1, 1, 2, 3, -4, -3, -4, okay, -4, 2, then we got a 0, 2. Okay, so we got plenty. There we go. So there's my quadratic. And the only thing left was the domain and range. Now, the thing about these quadratics, if they open up or down, the domain is always what? All reals. So if you didn't put all reals, you could put negative to positive infinity. Okay. Now, the range is what was going to be different. Does this have a minimum or a maximum? It has a minimum. So, in fact, what is the minimum? The lowest it goes vertically is -6. So it's going from -6 to infinity. Now, because -6 belongs to the vertex, I'm going to cap that with a bracket. It's included. Yeah. Give your back. All right, there we go. There's number one. All right, questions. Okay, and then we had number three. Let's see here. Number three, it says the graph of 2x squared plus bx plus c is shown, where b and c are constants. We want to know what is b times c. Okay. Well, which one of these do I immediately know, b or c? Remember, in standard form, this was one of the things that we knew immediately without having to do any work. Oh, what does c represent graphically? It's the y-intercept. Well, I'm looking at the graph. This is crossing the y-axis at -6, so I already know c is -6. Now, if I go straight down the middle of this parabola right here, I could use the AOS, or I could even go ahead and use the vertex. It doesn't matter, but either way, x is equal to -1. Okay. Now, what was that expression that was super helpful to me? The opposite of b divided by 2a. Well, we know that if I take the opposite of b and divide it by 2a, it should give me that value of x right there, -1. Now, we're trying to figure out what b is, but we do have a from the expression. So the opposite of b divided by, well, if I plug 2 in here, 2 times 2 is 4, is equal to -1, then I've given myself just a simple little equation. I'll multiply through by 4. So it looks like -b is equal to a -4, but I want b, so that means b is equal to 4. Okay, so what's b times c? -24. And there are other ways that you could have done that problem, especially with the graph, but based on what we've talked about so far, that probably would have been the way I think a lot of people probably did it. Okay, anything else? Number 4. Let's see here. So number 4, we are graphing this. -2x squared plus 8x minus 12. Now, we can already tell a couple of things. Would this parabola open up or down? Okay, it would open down. Okay. Now, this is an inequality. Is it a solid curve or a dashed curve? How do we know that? There you go. There's no equality. So whatever we get, it's got to end up as a parabola that opens down that looks like that. Okay, well, let's find the vertex. Here's A, here's B, here's C. Again, it's the same expression. The opposite of B over 2A. Let's put my vertex right here in the middle. So what's the opposite of B? -8 over 2 times A. A is -2. So -8 divided by -4, that's a +2. So now I'm going to plug that 2 back in. So f of 2 equals, we got a -2 times 2 squared plus 8x, so plus 8 times 2, and then minus 12. So let's see, 2 squared is 4, times -2 is a -8, plus 16, and then we have minus 12. Okay, so if you simplify that, we are going to get -4. And just like before, we're going to go ahead and count the x's. So this would be a 3, 4, 5. This would be 1, 0, -1. And we know that we're going to go ahead and see the symmetry, and then we just plug in these numbers. So I'll just go ahead and write these down. Okay, that will be a -22. Then we got a -12 and a 6. Oh, that's a -6. Excuse me. Okay, so let's see here. There's my origin right here. Calibration's off. Okay, so let's see. 2, -4. 1, 2, 3, -4. So there's the vertex. Okay, then I've got 1, 2, 3, 1, 2, 3, 4, 5, -6 right there. Okay, then we've got 1, -6. All right, so I'm going to have that dashed parabola right there. So it's right at the bottom of your grid. Okay. Now, the only thing I have left is what? The shading. Well, how do I know if I shade above or below? What's that? Okay. So we have y is greater than. So that means we're going to shade where? Above. So where am I above this curve? Everywhere outside. So the only place we're not shading is inside that tiny little quadratic. All right. Anything else? Hey. Okay. Hey. Sure. Get you back. Okay. All right. Any other questions? Okay. So if anybody scored below an 80 on this and you're looking to retake it, you can absolutely do so. You have until next Friday morning. So that gives you just over a week. But you do have to have the standard form of a quadratic assignment done before you go ahead and do that. Okay, let's put that to the side. Okay, now here is the vertex homework that was due today. We finished this up over the past 2 days. So did we have any questions on the vertex form? Remember, this was transformations and looking at this new form. No questions? We're confident with the transformations. Given a table, we can sketch one of these things, determine the vertex. Let's do one. Which one would you like? Or you just want me to choose one? Just choose one? Okay. How about, let's do number 8. Okay. So negative x plus 5 squared plus 5. Okay, so this wants me to find the vertex and the axis of symmetry and then graph it. Okay. Now, we don't have to do any work here. With vertex form, there's no opposite of b over 2a. Remember, you've got your a times x minus h squared plus k. So let's see here. Who have I not talked to lately? Tyler, what is the vertex from this function? Negative 5, 5. Here we go. Remember the h, that's the one that we take the opposite of. Okay. K, you do not take the opposite. You leave it as is. Now, we're going to count just like we did before. So this would be negative 4, negative 3, negative 2, negative 6, negative 7, negative 8. Just like before, I'm going to choose an x, we're going to plug it in, and then we simplify. Okay? Very consistent process. Let's start with negative 4. Okay? So f of negative 4 equals, so we have a negative of negative 4 plus 5 squared plus 5. Okay. Now just follow through your order of operations. Let's start with the parentheses. What's a negative 4 plus 5? Okay, so that's 1. 1 squared is 1, and now I apply the negative. That's the last thing. So this is a -1 plus 5, so it looks like I'm getting what? 4. So that means -6 will also give me 4. Okay, remember, you're still seeing that symmetry. Okay, so we know how to do that. I'm just going to go ahead and fill in the rest of the table. This should be a -4 and a 1, so that would be a 1 and a -4. Okay. And you can check me, go ahead and plug those in. Okay. All right, let's see here. So -5, 5, -1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here is my vertex. Okay, -6, 4 would be right here, -4, 4. Okay, -3, 1. Okay, -7, 1. That's more than enough points. Let's go ahead and connect this. There we go. Now, we already found the vertex, but it wants the AOS. So there's a couple of ways I could do this. I could go ahead and draw a line straight down the middle of this and see where it's touching the x-axis, but there's a faster way. Remember, it's the x value of your vertex. We always want to say x equals because it's a line. All right. Question. All right. So, yes. Oh, you got your badge. Okay. You have a quiz over this on Monday. Okay, so quiz over this material on Monday. All right. So, if you do have any questions, hey, number 12? Sure. Number 12. Now, I'll go ahead and say something about these right here. Let me go ahead and erase this. So numbers 11 and 12, what are those? Remember, those are piecewise functions. Okay? Right now, you're not going to be responsible for the piecewise functions. Okay? Like I said, at some point, we are going to go ahead and spend a lot of time on those, but for right now, we're just going to go ahead and kind of go past them. Okay. All right. Ooh, excuse me. All right, that's 20 minutes. Okay. Cool. All right, so here we go. We are starting our new lesson. Okay. So hopefully you went ahead and took a look at that little factoring guide that I gave you with those extra problems, or maybe you're looking at your factoring packet, but if you'll put it in the 7th period tray, please. Okay. Hopefully you're feeling good about factoring. If not, you're about to get a lot more practice. All right, so solving quadratics by factoring. So what we're looking for here is graphically where it crosses the x-axis. And there's a lot of different ways to do this. We're going to start with factoring. We're going to move on to completing the square, quadratic formula. By the end, I'm going to let you choose whichever one you like the best. As long as you're able to solve, that's all I'm interested in. Okay. Let's see. For factoring specifically, what do? We're going to move all terms to one side and set the equation equal to 0. If you're going to factor, it has to equal 0. Then we're going to factor using whatever strategy is available. Set each factor equal to 0 and solve. This is what we call the zero product property. And then we're going to write my answer as a solution set. So we're going to use these squiggly brackets right here. Okay. So we're going to go ahead and run through this. We're going to alternate. Okay. As you go through, you'll notice like 1 and 2, they're very similar type problems. Okay. 3 and 4 are the same. So every time I do one, I'm going to give you a few seconds to try one on your own, and then we'll go ahead and talk about it. Okay, so let's start with 1. Solve each by factoring. Well, x squared plus 9x equals 0. Okay. Now remember, what is the first rule if you're going to factor anything? Look for a GCF. Okay, that's what these are. Do x squared and 9x share anything? They share x. Okay, so I'm going to break this apart and say x, but x times what? X plus 9 is equal to 0. Remember, what I'm looking for here are the values of x that if I were to plug them back in, it's going to make it a true equation. Okay. Well, this is what we're talking about with the zero product property. Once you've got it factored, look at each part and set those equal to 0. So x equals 0, I don't have to do anything. That's already my first solution. But the other part, x plus 9, if it equals 0, x equals what? Negative 9. So I guarantee if I were going to go ahead and graph this quadratic, it is crossing at 0 and negative 9 on the x-axis. Okay, guaranteed. So I'm going to write this as a solution set. Okay, negative 9, 0. Now here's the thing. People always ask me about this. Okay, we want to go ahead and write my answers as a set. Okay, it's preferable that you go ahead and put those in order. But what if you put 0, comma, negative 9? Is that going to count off any points? Probably just a few. I'm kidding. Okay, I'm not going to count off points for that. Okay, here we go. So questions on number 1. Okay, number 2 is a very similar problem. Try it. So what's kind of nice about this is that we're going to be able to kind of learn this new idea, but at the same time get practice with factoring. I cannot stress how important a skill that is, especially if you're going to move forward in mathematics. Okay. What's GCF for 4x squared minus 8x? Okay, now 2 is, but you can go bigger. So 4x. If I pull out a 4x, what's left? X minus 2. This equals 0. Each part of your product, that's what you set equal to 0. So if 4 times some unknown value, x equals 0, what's my first answer? X equals 0. Okay. If the other group, x minus 2, is equal to 0, add that 2 over, bless you, x equals 2. So here are my 2 solutions. Okay. If I put either one of those back into the equation, it will make it 0. That's what we're looking for. How many people got that? Fantastic. We're off to a great start. Okay. Let's move on to the next one. Okay. Now, number 3. Now, this one doesn't have a GCF, but does anybody recognize it? There we go. We are subtracting 2 what? Perfect squares. This is a difference of squares. A squared minus b squared. Remember, we get groups that we call conjugates. A plus b, a minus b. Okay. We find a and b by taking the square root. What's the square root of x squared? X. So a is x. And what's the square root of 4? 2. So if I'm going to take these values and write my factored version, would that be x plus 2 times x minus 2 is equal to 0. See, all I did was factor the left side. Now what? Set them equal to 0. So if x plus 2 equals 0, x equals negative 2. If x minus 2 is equal to 0, x equals 2. Now, when you write your solution set, you can go ahead and write them separately. You can go ahead and say 2, comma 2. That's perfectly fine. Or if you just want to combine them and say plus or minus 2, that's perfectly fine as well. Okay. All right. Now that you've seen that, try number 4. Find me the solutions. are going to notice something about number 4. I'm going to tell you it's okay. Okay. So is there a GCF? No, GCF? Okay. So it's another difference of squares. What are my conjugates? 3x what? Plus 5? Bless you. And then 3x minus 5. And someone out there might be thinking, does it matter the order? Like if I put 3x minus followed by 3x plus, does that change anything? Not a thing. Okay. Take the two terms, set them equal to 0. So if 3x plus 5 is equal to 0, so this is a two-step equation, subtract the 5, and then divide by 3. So what was I referring to a moment ago when I said it was going to be okay? You got a fractional answer. That's very possible. There's nothing wrong with that. Okay. Now the other one, 3x minus 5 is equal to 0. Add the 5 over, divide through. Okay, so we should have gotten plus and minus 5/3. How'd we do? Fantastic. Now at any time, if you're not sure how we got something, definitely let me know. Okay, we're moving on. So we had difference of squares with the binomial. Number 5, we're into the trinomials. Okay, but is this a simple or a general? Simple, how do we know? There you go. It's a simple trinomial if the leading coefficient A is 1. So here, it's just a guess and check. What two numbers would multiply to give me 21, but those same two numbers have to add to give me a negative 10? Negative 7 and negative 3. So x minus 7, x minus 3. See, negative 7 times negative 3, there's your positive 21. Negative 7 plus negative 3, there's your negative 10. Okay. All right. Set these equal to 0. So if x minus 7 equals 0, x equals 7. X minus 3 equals 0, x equals 3. There we go. So see, the thing about this lesson, if you feel really confident with factoring, it's going to be a breeze. Okay. If you're struggling with factoring a little bit, you're probably going to struggle a little bit because that's what's going to get you your solution. Okay. Try number 6. Now, it doesn't look like it, but this is going to become a simple trinomial as well. Okay. So it doesn't look like a simple to me. What was I referring to? There's a GCF. Okay, so I'm going to factor out a what? 2. All right. So that's going to leave me x squared minus x minus 12 is equal to 0. Now, this 2 right here, I don't have a variable with it. So I don't have to worry about it anymore. Remember, we're trying to solve for x. Now, if it had an x, then I would definitely care about it. All right. Let's see. What two numbers will multiply to give me 12? but had to give me -1. Okay. So it's got to be x minus 4 times x plus 3. Now, quick question. X plus 4 times x minus 3. 4 times -3 is still -12. What's the problem? What's a 4 plus -3? +1. See, we need a -1. So that's why this version doesn't work. You got to make sure that your signs are correct. Okay. And then, zero product property. If x minus 4 equals 0, x equals 4. If x plus 3 is equal to 0, x equals -3. So we have -3 and 4. How are we doing? Okay, how many people got that right? Okay, this is good. This is good. Okay, we're continuing to move up. Okay, now you take a look at number 7. There's no GCF. This is a genuine general trinomial. Okay. Now, what was the method that we talked about? My father drives a red Mercedes convertible. Again, if you like that method, great. If you were like, I hate that method, great. But you still got to find a way to factor a trinomial. Okay. So, what does that M in my stand for? Multiply. So what am I going to multiply? So the leading coefficient and your constant. So 3 times -30, that's a -90. Father, what does that F stand for? Factor. So I got to find two numbers that will multiply to give me a -90, but then they also have to add to give me a -13. Okay. So all I know for sure, because it's a negative product, I got a negative and a positive. This right here can be the most difficult part. But I guarantee once you find those two numbers, the rest of it goes pretty quick. So, ideas. Okay, Elliot, what you got? -18 and 5. And really, it's just experience. I hate to say it that way, but there's no way to immediately focus in on what two factors are going to work. The best thing I can tell you is just start listing all the factors. Like, for example, 1 times 90 will give me 90, but there's no way that's going to give me a 13. Then we have 2 times 45, 3 times 30, but you'll notice the factors are getting closer together. Okay. So sometimes the best way is just to list them out, maybe do some multiplication, see what works. Okay. Is everybody okay with that? All right. Now, my father drives. What is that D? Divide. What do I divide by? Always divide by that leading coefficient. So by 3. See, once you've got those factors, the rest of this problem is going to go super quick. Okay. A red. What's that R stand for? Reduce. So we have 5/3. -18 thirds is a -6. So remember, if it divides evenly, put it over 1. Okay. Mercedes. Now we're ready to move these. So I'm going to put the variable in each denominator, and I'm going to read it from the bottom up. So -6 over 1x, that would be x minus 6. What's the other one? 3x plus 5. There you go. And then zero product property. Okay. So if x, almost with the answer, x minus 6 is equal to 0, x equals 6. If 3x plus 5 is equal to 0, subtract the 5 over, divide by 3, so we have a -5/3. Okay. There we go. So I'm going to write it as a solution set. We got -5/3 and 6. All right. Okay, your turn. Solve number 8. Same way. If you don't like the my father method, okay, you could guess and check. There's the box method, grouping, A lot of stuff. Now, this one as well, you know you're on the right track. You should be getting fractional answers, okay, for both. So hopefully you've gotten over that hurdle. You found the two factors. Let me start catching up. Let's see. Multiply 6 times -4, -24. So I'm looking for a negative and a positive, but they have to add to give me 5. 8 and 3. Which one's negative? Okay, has to be -3, +8. See, that one was a lot better, right? They won't always be huge, but if you get a huge product, don't let it intimidate you. Okay. So what do I divide by? 6. That's what starts it. -3/6 is a -1/2. 8/6 is 4/3. Okay. Now I'm ready to create my factored answer. So I'm going to put x in each denominator, and I'm going to read it from the bottom up. So what's my first group? 2x minus 1 times what? 3x plus 4. Now, if you have time, it is not a bad idea. Multiply those back together, see if it does give you the original problem, because your solutions are going to be based on this. Okay. Let's see. If 2x minus 1 is equal to 0, okay, if I add the 1 and divide by 2, first answer you should have gotten is 1/2. Okay. Followed by 3x plus 4 is equal to 0. Subtract the 4, divide by 3, second solution. -4/3. There we go. -4/3. Ooh, interesting. And a 1/2. Okay, how we doing? Hey! It does not. It does not. So if you put the positive before the negative, this is one of those rare occasions. I'm not going to do anything. Okay. All right. Well, how are we doing? Okay. I'm just going to quickly show you one more, and then we are done. So flip that page over. 2x squared equals 5x. Now, starting with number 9, how are these different? There you go. If you're going to factor, it has to equal 0. Well, that's a quick fix. All I got to do is subtract that 5x over. So 2x squared minus 5x is equal to 0. Okay. And then run through the process again. Is there a GCF? Yeah. What is it? X. So what's left if I pull out an x? 2x minus 5. There's nothing left to factor. Now I use the zero product property. Okay, so the only difference is I've got to get everything equal to 0 before I start. So x equals 0, that's one solution. If 2x minus 5 equals 0, if I add 5, divide by 2, 5/2. There we go. So for tomorrow, only less than 30 seconds, you should be able to do this. Take care of number 10. Take care of number 10. We'll start there tomorrow. We'll go ahead and wrap this up. We'll have SEL. Okay. Great job today, folks. Fantastic. Thank you, thank you, thank you, thank you. Yo. Oh, yes. If you have the vertex homework and you want to turn it in, go ahead and do that. Pass it on up. I'll take it.